Hello, in this lesson we're going to talk about measurement problems. So our first objective is that we're going to use a bar diagram to solve word problems. This is just a review for Math 210. And objective 2 is we're going to define properties of points, lines, and segments. So we're just going to go over a bunch of definitions. Alright, let's get started. So first of all, what's a bar diagram? A bar diagram is simply pictures designed to display the reasoning used to solve word problems. Okay, so we're just going to draw a picture of the word problem that we see. So our first example, we have a bookcase and it contains two rows of identical textbooks. One row is 18 inches long, the other is 24. The longer row contains 4 more textbooks than the shorter row. How thick is each textbook? So let's draw a picture of what's going on. So we have row 1 and we have row 2. So I'm just going to draw a box to represent row 1. Now we said that row 2 is longer, so I'm just going to draw another box, one that's a little bit longer. Row 1 is 18 inches. Row 2 is 24 inches. And I'm going to draw my line right here. They said that there are 4 textbooks inside that extra space in row 2. So first of all, before we even worry about those 4 textbooks, we need to figure out what this distance is from this point to that point. Well, this is a subtraction problem. So we're going to take 24 minus 18 and we get 6 inches. And I'm going to keep my labels. Now, that's our 6 inches right here. That 6 inches is divided up into 4 books. So we're going to take 6 divided by 4. So that's 2/4, which is 1/2. So the answer is each textbook is 1.5 inches thick. Okay, so that's our first bar diagram. Here's another example. It says Katie bought 2.4 meters of ribbon. She used 1/3 of it to wrap a present and 1/4 of the remainder to make a bow. How many meters of ribbon were left? Okay, so first of all, we draw our ribbon of 2.4 meters. So this is 2.4 meters. And first she used 1/3 of it to wrap a present. So we're going to just put the word wrap here. And she took and she divided up into thirds and she used 1/3 of it. Okay, so then really what we care about is we care about what remains. Okay, so I'm going to redraw that. And she said she took 1/4 of the remainder to make a bow. So this is our bow. And she took 1/4 of it, so I'm going to divide it up into fourths. So here's 1/4 of it. And so the question is, how many meters of ribbon was left? So we are looking for this spot right there. Alright, so first of all, let's figure out what each piece is in our wrap. So if I take 2.4 and I divide that by 3, because I had 3 pieces, then I get 0.8 meters. So each section is 0.8 meters. Well then, if I take 0.8 times 2, I get 1.6 meters. And so that 1.6 meters will represent how much she had when she started to make the bow. Now, she took that bow and she only used 1/4 of it. So if I take that 1.6 and I divide it up into 4 sections, I get 0.4 meters. So that means that each part of these is 0.4. So now all I care about is the remainder, so I take 0.4 times 3 and I get 1.2 meters remains. Okay, so that's example 2. Alright, now let's go to objective 2. Objective 2 is to define the properties of points, lines, and segments. So before we can even start, we have basically 2 basic principles of geometry. The first basic principle is through any 2 different points, there's only one line. This is actually very much a lot of common sense. So if I draw 2 points, here's point A and here's point B. Basically, I can only draw one line that goes through them. I can't draw anything else. Okay. The second basic principle, if 2 different lines intersect, their intersection is a single point. So if I have 2 lines, here's my first line. I can draw my second line anywhere I want, as long as it intersects my first. My intersection will only be 1 point. I'll never have more than 1 point. Okay. Very basic, but we're going to use it a lot later on. Alright, so let's start talking about some definitions. First thing we have to do is we have to talk about a point. A point is a dot in a plane. Well, that's pretty simple. It's just a dot, and we usually label with the capital letter. Point A. A plane is a flat 2-dimensional surface that extends infinitely far in all directions. So if I draw a plane, it's just a flat surface, and I'll draw it looking like this. It's kind of like a piece of paper. And all you're going to do is you're going to take that piece of paper and you're going to stretch it in all directions. And that's a plane. Right? You can have planes going up and down, left and right. You can have planes in all kinds of directions, but it's only a flat surface. Alright, let's talk about a line. A line is formed by infinitely many points extending in both directions. Alright, so when I talk about a line, kids they know what lines are. You just keep drawing. And we show arrows to say, hey, it's going to go on forever. Now here's the deal. When we talk about a line, I want you to think about infinitely many points. I want you to think about the pixels on a computer screen. The more pixels I make, so the more points I make, the more a line forms. So let's put some points right here. So if I keep putting in more and more points, my line becomes more and more defined. And that's all a line is. It's just a series of dots, a series of points. So I want you to remember that. Alright, how do we label a line? Pretty simple. We find 2 points on a line, any 2 points you want. We usually use capital letters. And we just write line AB. Or you could go the other direction, say A line BA. It doesn't matter. Okay? But that's how you label a line. Alright, so if that's a line, what's a line segment? A line segment is just part of a line between 2 points. So before, when we drew a line, we kept the arrows going, but now when we draw a line segment, we want that line segment to stop. We want a specific measurement. So we label it AB. When we label it line segment AB, or we could say line segment BA. Order doesn't matter with line segments either. But order does matter when we talk about rays. Rays is part of a line on one side of a point of the line. Okay, so basically it's a line that goes in one direction. So we have an end point, and we're going to go in one direction. That's a ray. So when we label rays, we can't use one letter. We still have to use 2. So we just pick a point. Here's the important part for labeling. When we label a ray, we always have to start with the end point. So here my end point is A, so I got ray AB. I cannot have ray BA in this case. Now let's say I draw another ray, but this time I'm going in this direction. I label this A. I label this B. Okay, B is my end point, so when I label my ray, I have to start with B. Always start with your end point because that tells us where it's starting. And the arrow doesn't matter which direction you go. I like to go the direction of the ray. It gives me a little bit more information when I label. Okay, next word we're going to talk about is collinear. Collinear is when we have three or more points and they are contained within one line. So basically, if I draw 3 points, A, B, and C, and if I could draw a straight line through them, that means they're collinear. Easy enough. Now, non-collinear means, hey, they're not going to land in one straight line. So non-collinear, 3 or more points that are not contained within one line. So let's say I'm just going to use 3 points. You could use 4 or 5. So if I have A and B, there's 2 points. Well, my third point can't land in the same line. So here's C. And if you notice, 3 points will always form a triangle. Let's make that straighter. There it is. Okay, so that's non-collinear. If we had 4 points, it would form a quadrilateral. So, the reason we're spending a lot of time talking about the triangles, we're going to talk about this property later on. Okay, we have 2 more words. Collinear measurement and non-collinear measurement. Alright, think about collinear. Collinear meant that we were in a straight line, right? So if we have collinear measurement, we have our straight line. So let me draw my straight line with 3 points in it, because they're collinear. Let's label them A, B, and C. Now when we talk about measurement, we're talking about the distance. So we're saying that line segment AB, so I'm going to write it over here. If I add it to this distance, line segment BC, I'll get my total distance, which is line segment AC. And that's what collinear measurement means. You're going to take the 2 distances inside, you're going to find the total, and you'll get the whole thing. Okay, now non-collinear means we're not in the same line, right? So we formed a triangle is what we formed. So in any triangle, the length of the longest side is less than the total length of the other 2 sides. Alright, so let's label this A, B, and C. Okay, what they're saying is this. Is if I take line segment AB and I add it to line segment BC. So we're going to take AB plus line segment BC. Oops. I don't want equals. There we go. How does that relate to line segment AC? Well, let's look at this for a moment. Let's take this, let's put it right there. So here's my AB. Okay. Now let's take this one and let's just move it right here. Okay, and that's C. Alright, now let's just take my bottom one, and there's my AC. And what do you notice? I think that AB plus BC is longer than AC. So that's the relationship. What that's saying is when you add the 2 segments together, they're not going to be equal to the third one. They're going to be a little bit longer. Okay? And that's just section 1.1, where we talked a little bit about bar models and a little bit about some definitions of lines. All right, thank you.